So hello all, I welcome you to this lecture in which I am going to discuss the previous paper of design analysis of algorithms. So the syllabus for the new revised MC syllabus and the old, which is MC 31, is same, right? Both the syllabus are same and except the few algorithms, and that I will tell you that what is not in your syllabus, right? So I will discuss only those questions which are in your syllabus. So almost there are all the questions that are asked in this paper are from the new syllabus, right? So there is no changes. So in which they have asked you. Let's talk about this first question, right? So the first question says that the multiply the following n-digit decimal numbers x and y using the Karatusba technique, where x's and y are the n-digit decimal numbers, right? Note down this decimal number, right? Okay. So right. So I will give you an example and then will tell you the algorithm. What is the algorithm of right? The algorithm for this. So we have this question number 1, right? Question number 1a, right? And which ask you about this Karatusba algorithm, right? So Karatusba algorithm is used to multiply two decimal numbers, right? And we know that what is the decimal numbers, because from our childhood we are using the decimal number systems which have the numbers from 0 to 9, okay, and all the combinations of these numbers, right, like 1 2 3 and up to infinite. So these are the decimal numbers, and I hope that you know what is a decimal number, obviously, right? So this algorithm is used to multiply two decimal numbers, right? I'm writing here used to multiply two decimal numbers, two decimal numbers. Okay. And what are the decimal numbers, sir? The decimal numbers examples are like, if you have this number, right, 1, 2, right, 3, 4, right? This is a decimal number, and we want to multiply with this another number which is like 2, 6, 4, 0, right? So these are the two numbers, and these two numbers are the decimal numbers, okay? So let's say this is x and this is y. So what this algorithm is all about? This algorithm is all about the multiply the two decimal numbers, right? So okay. So in the exams they have given you like this, right? Because these two numbers are obviously these are of the same length, right? So they have denoted this number as x n minus y, comma x n minus 2, right, comma x0, and you know the x0 is your unit place, right? X0 is unit place, as we know in our decimal, right? Unit place, and then this is 10 place, then 100, then 1000, and then 10,000, right? Okay, now the number is y n minus 1, y n minus 2, and till, right, y naught, right? Again this is same as this x, right, because these are the numbers. Okay, so what is the algorithm, and what are the steps, various steps in this? So in these algorithms, the first is, right, they represent these numbers in a very different way. So they represent x is like x is x h, right? B n by 2 plus xl, and y is represented as, which is another number, is represented as yhb n by 2. This is h, okay, don't confuse with the h and n. This is h, this is n, plus yl, okay. So xs is your the highest number, right? X high and x low. So I just write here x h and x low, and h denotes for high, right, and l is for low. So if I represent this number, so this is your xh, this is your xl, right, this is your yh, right, and this is yl, okay. So the first step is this, right? So in the step 1 of this algorithm, we have to represent this like that, okay. So, and now these meanings are clear, xs, yl, and yh and yl. So xh is 12, xl is 34, yh is 26, and yl is 40, right? And what is the b? B is base. B is base, and what is base? Base is your the total numbers, right, that are present in a particular number system. So we are using their decimal numbers, right? So for the decimal we have 10 unique numbers. So the base will be 10. So the value of b will be 10. Okay, that we write it again here. Okay. So here if I represent this equation, right, x and y, so I will write, so for example I have taken these two numbers, so I will represent it like x is equal to xh is your 12 multiply by base, right, base is your 10, and okay, n what is n? N is the total number of digits. So total number is digits are 4, right, so n is 4, so we will write as xh into 10 raised to power n by 2, n is your 4 by 2, right, plus xl is your this number, right, 34, right, and like this we can represent y as yh is your 26 multiply by 10, because base is same, base is 10 and n is 4, so 4 by 2, right, plus yl is your 40. So this is your x and y. So right, okay. Now the step 2 is, so what we are will do in step 2. Step 2 is your xy, means your multiply, because you are multiplying with these two numbers x and y. So xy will be your like xh yh b n plus xh, right, xh and yl, okay, plus xl and yh, right, multiply by b raised to power n by 2 plus xl and yl. So put all the values of xh, yh in this equation and you will get the multiplication of x and y. So xh is your what is xh? xh is your 12, yh is your 26, then b to the power n in the 10 raised to power 4 plus xh 12, yl is your 40, right, plus xl, right, xl is your 34, right, and then yh is 26, okay, and then divided by, multiply by b raised to power n by 2. That means n is 4 and 2 plus xl and yl. So multiply with these xl and yl this. So that means 34 into 40. So 34 into 40. So after calculating this number, you will get an answer. Okay. So this is your algorithm for n digit decimal numbers x and y using the Karatusba technique. Okay. So I hope that it's easy actually. If you do this two to three times and you practice it, or you watch it and then write and then make notes for this, and you will understand. Okay, that this method of Karatusba to multiply these two numbers x and y, or whether they have given any numbers, right? A and B and B and C and C and D. Okay, this is just notation, right? Now the second question is, which is your question 1b. Okay, it says, as you can see in this example and in this paper, right? This is of 5 marks, and they have asked you about the sort the following sequence in ascending order using insertion sort. Okay, so it's again it's a very easy question, and in your exam they are going to ask one of the sorting. So the question from sorting will be like a mandatory question, right? Because as I have seen that in almost all the years they have 2 to 3 questions for these sortings, right? Like your merge sort, insertion sort, heap sort, quick sort, bubble sort, right? So in this they have given this 28, 13, 12, 25, 38, 11, 15, 9, 36, and they are going to ask that using the insertion sort technique you have to sort these numbers. So I am explaining you the each and every step of this question, right? So they are asking 28, right? 28 and 28 and 13, right? 28, 13. Wait a second. Wait. Okay. So this is a 28, 13, 12, then 25, then 38, then 11, then 15, then 9, and then 36. So this is your question, and it is given that these are the numbers and you have to sort in the insertion sort using the insertion sort algorithm. So for this step 1 in using the insertion sort technique, right? So let me write the insertion sort here so that you did not confuse that which sorting algorithm I am applying to it, or I am using this, right? Which algorithm I am using, right? So 28, right? So according to the insertion sort, that it assumes that the first element is already sorted. So this element is already sorted, which is your 28. Okay. So this is a sorted element, and now it compares with this. So the loop starts from here, from 13 till the end. So from 13 you start. So just pick up this number and then insert it into its proper place. So we compare 13 to 18, right? Let's compare this 20 to 13, and then we find that the 13 is the less than 28. So in this step, the 13 will goes here, right, at this place. Okay, let me delete this first, and so because this 13 is less than 28, so we will exchange this and then we'll write 13, 28, and all other numbers will be same. 12, 25, 38, 11, 15, 9 and 36. Okay, and in the next step, because now these two are sorted, right? Now in the step 2 we compare this number, right, 12, this number first to 15 and then to 13, right? And we insert this 12 at its proper place. So this is the idea behind the insertion sort. So because when we compare 12 to 28, it is less than, so it will come here, right, 12, 28, and then we compare with this 12 to 13. So 13 is obviously 13 is greater, means 12 is less than 13, so the proper place will be here. So 12, 13, 28, right? And then the rest of the element will be 25, 38, 11, 15, 9, 36. So this is your second step. Now in the third step, in the step third, what we will do, we will because these three are sorted now, and we pick 25 and then insert it at its proper place. So we compare with this 25 to 28. Obviously 25 is less than 28, so we will exchange 25 to 28, right? And then we will compare 25 to 13. So because 25 is greater, so it will be here only, and then 25 to 12. So 12 is again less than 25, so it will be remain here, right? So in this step we will write 12, 13, 25, 28, 38, 11, 15, 9 and 36. Okay. Now in the next step, which is your step 4, right, is so now these all 4 elements are already sorted, and in the step 5 we will pick 38 and will insert it at its proper place. So because 38 is obviously greater than 28, greater than 25, and 13 and 12, so it will remain here only. Okay, so right, so you will see that the 38 is already greater than these 4 elements, so it will remain at this place. So I skip this step. So again I will compare with this 11. So all obviously when I skip this statement, this step, so this 12, 30, 20, 25, 28, 38 are already sorted. So we pick 11 now. So when we pick 11 now, we will find its proper place. Now because I have already completed 4 steps, so you have got an idea that how to sort using the insertion sort. So the 11 will be at this place, at the first place. So we'll write 11, 12, 13, 25, 28, 38, then 15, then 9, then 36. In the next step, is step 5. It will be, now these all are sorted, right? From here to here, these all elements are sorted. Then we pick 15, and then we have to fix, or we have to insert it at its proper place. So the proper place will be of this, because it is less than 38, less than 28, and is less than 25, but is greater than 13. So we will write 11, 12, 13, 15, 25, 28, 38, 9 and 36, right? So now let me insert a page right at the end, right? So here in this step 6, in the step 6 we will sort it like 15 will be at this place. So now this much is already sorted, these numbers are already sorted, so we have to find a proper place for the 9. So 9, because 9 is less than from these all the elements, So 9 will be at first place. So 9, 11, 12, 13, 15, 25, 28, and then 38, and then 36. Now okay, in this step we have already sorted these elements. Now we have this 36. So we have to insert this 36 at its proper place, and its proper place will be before 38, right? So now in this step, this is your last step. So it will be like 9, 11, 12, 13, 15, 25, 28, and then 36, and then 38. So now your array or list is sorted. So this is all about the insertion sort. Okay. Now the next question is question number 1 of C. It asks about the asymptotic notations, right? So differentiate between asymptotic notations, big O, big omega, and theta notation. So this is the definition they are asking about, and so this is the direct question, right? Okay, now let's see the definition of these notations, and on basis of these notations they have asked you so many questions that are based on the reference relations and based on master theorems. So you must know about these notations, right? Asymptotic notation, they are known as asymptotic notations. So first, the big O. So what is big O? And so big O is your, right, it is represented like O. Okay, so this is big O, right? So the definition says if we have two functions fn and gn such that, okay, that when, if this is graph like this, right, if this graph, the graph of this is like this, right, we have this fn function, it is like this, right, this is your fn, and this is your zn, right, this is your zn. Okay, so if we have these two functions f and gn such that, in this way, and this x-axis represented n is the number of inputs. So it means as the number of inputs grows, number of inputs grows. So if you have 2 numbers, 3 numbers, 4 numbers, 5 numbers, so the number of inputs or the input size is increasing, as well as the time will increase. Okay, because this is a plot between the size of your input and the time. Okay, so, and this place is your, let's say this is n naught, right? So after this n naught, the gn is greater than fn. After this n naught, after this value of n, right? Okay, so it says that fn and gn are two functions such that if fn and gn are two functions such that fn is less than equal to gn with some constant c, right, with some constants c. This is the symbol of greater than, and this is your c, right? So, and where c is greater than 0 and n naught is greater than 1. It means n naught is greater than 1 because there must be at least one input, because so that's why they are saying n naught is greater than 1. So if this is the case, you know, where c and n, where c is greater than 0, n naught is greater than n, and c and n are real numbers, okay, are real numbers. So we say that fn is big O of Gn. Okay, so it represents the upper bound actually, right? You can write as well C here, right? So if this is the case, then we say that fn is big O of Gn. So this is the definition for big O. This is the definition for big O. Similarly, if this function is like that, right? If this function, these two fn and gn are like that, okay, let me plot this again between n and t, right? n and t, such that this is your right. Okay, so this is, and here this we have this, right? So this is your fn, this is your gn, multiply with some constant c, right? So, and this is your n naught. So the definition is same, like fn and gn are two positive integers, and two functions like that fn is, now because cgn is denoting the lower bound, so fn is greater than the cgn, because okay, so fn is greater than equal to cgn. So we say that fn is omega of gn, right? Omega of gn. So this is for your omega notation, right? This is big omega. This is big omega. Excuse me. So big omega. So it is denoted as this. So this is the definition for big omega. And obviously, you know, where c and n are real numbers, such that c is greater than 0 and n naught is greater than 1. So we say that fn is omega of gn, right? So if you want me to explain this in more detail by taking some examples, so I can do that. Let me know in your comment section that if you need this to understand the concept with the example. So okay, because in exams they are going to ask you about some questions, if two functions are big O of or big omega or theta. Okay, so I will make another video for that. Now we have this big theta, right? Big theta, or we can say only the theta notation, right? Big theta or theta notation. It is represented as this. So it says that if this is, I'm plotting this graph again, okay, plotting this same graph again between fn and gn, okay. So this is like, this is your fn, this is your right c1 gn, right? This is your c2 gn, right? So if this is the case, so let me write this constant is same, so c, so this constant is same, the functions are different, okay. So take this function as gn, g1n and g2n, okay. So if this is the case when fn is right, like g2n is greater, so we will write g2 here or g1 here, right? And c when gn is less than, so we will see that right? This is like G2n and is greater than Z1n, right? Z1n. So if this is the case, so we say that the Fn is sandwiched between the C and between the G1 and G2, between these two functions, where C and R are real numbers and C is greater than 0, and here we have this n0 is greater than n, right? So this is the case for the big theta. So in that case, what we have understood that Fn big O will give upper bound, right? Will go upper bound. It means the worst case. Okay. This is your because big omega is the lowest, or this represents for the lower bound. It represents the lower bound because Gn represents the lower bound. So we say that this is your this is the case when we found the best case scenario, right? Okay, and the theta is the medium or average case, right? It represents the average case, right? It represents the average case. Okay, so I think these three definitions are clear to you. So what we have to do, you have to remember only the first definition, which is your big O, and then omega will be your lower bound, and the big theta represent the your medium value or the average value, right? Okay, now the next question is that they have asked in your exams is this minimum cost spanning tree, right? Minimum cost spanning tree. So using the prim's algorithm for the following graph, right? But they have also asked you what define minimum cost spanning tree. So means such a tree that which has the minimum weight, okay, on all these vertex or edges, okay. So we have two algorithms to solve the minimum cost spanning tree problem, is prim's or Kruskal. So because they have asked you in this question prim's algorithm, so I will explain the steps of the prim's algorithm, right? Okay, so I have to write this graph. Okay, so this is your, I think this is your D question, right? This is your 1, 2, right? Here 1, 2, okay, 1, 2, 3, right? We have here we have 4, 5, 6, right? We have 4, 5 and 6. Okay, let me write this one is between 2 and 3 as given in the exam. So here is we have so this is one as between these two vertices, right? So this is connected graph, right? It's not fully connected, as you know, because there is no edge between each vertex to another vertex, so we cannot say that this is completed, but this is connected graph. Okay, so let me write the weight for these edges. Okay, this is your 10, 8, 7. Okay, now we have this 9, we have this 12, 13. Okay, let me see, 12, 13, 11. Okay, this is 12, this is 13, this is 11, this is 6, right? And this is 15 and this is 18. Okay, now according to the prim's algorithm, right? According to the prim's algorithm to find the shortest path or minimum spanning tree, minimum weighted spanning tree, what we have to do, we have to focus on the vertices, right? So we have to cover and we have to take all the vertices such that the vertex are connected, all the vertex are connected to each other but doesn't form a cycle. साइकिल नहीं बननी चाहिए, आपको इस तरह से वर्टेक्सेस एक दूसरे से कनेक्ट करने हैं, एंड बाय टेकिंग द मिनिमम वेट ऑन द एजेस, राइट. सो वी हैव टू पिक अप द वर्टेक्स in a way that the edges between these two vertices or between any pair of vertices is of minimum weight. So I'm not going to write the steps of the Prim's algorithm, but I'm going to solve this question only because they are not asking about how write the various steps of Prim's algorithm, what is the Prim's algorithm, but they are asking about to solve this problem using the Prim's algorithm, right? So what you have to do, you have to write all the vertices, only all the vertices, right? So as I'm writing 1 2 3 4 5 and 6. This is a very simple way, okay? This is very simple way. Now we will choose the edges which are connecting the vertices have the minimum weight. So out of these vertices, and which pair of A's has, or which A's has the minimum weight or the lowest weight in this graph. So this is 10, 9, 15, this is 7, this is 8, this is 13, 12, 6, 11, 18 and 15. So 6 is the minimum weight it is. So this as. So we pick this. So we will pick this as which is connecting 3 to 5 with the minimum weight which is 6. Okay. And then we will pick the next minimum out of all the edges. So because we have picked up 6, so we will left this, and now we'll see this is your 7, 8, 9, 13, 11, 12, 15 and 18. So this one is your the next edge which have the minimum weight. So we will pick this 7, right? So it is connecting 2 and 4. So we have covered 4 vertices, right? Still 2 vertices are left. Okay, now the next vertex will be of this 1 and 4 because the 8 this is the minimum weight of the remaining edges. So we will connect 1 to 4 like this, right? Now we have the minimum weight is 9, right? So we pick this. So 2 to 3. So this is 9. Okay. Now, but the condition is that it doesn't form a cycle. Okay, it doesn't form a cycle. Okay, and what is cycle is? Cycle is, it is like a loop, right? So we are the circuit is when we start from one vertex and we reach to that vertex. So the starting and ending vertex is same. So we say that it forms a cycle. If I connect 4 to 5, then it will become a cycle. If I connect 3 to 4, it will become a cycle. So we have to avoid that. So this is your minimum, that will be your tree. Okay. So now, so which age we have to pick now? Because we have picked 8, 7, 9 and 6 already. So we are left with 10, 12, 13, 11, 15 and 18. So 10 is the next ages that we can pick. Right. So if I pick 10, so now this is the minimum weight, but we cannot pick it up. Because why we cannot pick it? Because if we pick it and we connect this, so it will form a cycle. But the condition is that it doesn't form a cycle, so we will ignore that. Now we find the next edge which is the minimum. So here we have 11, 12, 13, 15, 18. So the 11 is the next weight is that we can pick between 4 and 5. So if I pick this 4 to 5 with 11 weight, so again that will form a cycle. So we will not pick that. Then we have this 12, right? Because we are left with the 12, 13, 15 and 18. So if I choose this 12, this is between 4 to 5. So again 4 to 5, 12, then it will form a cycle between 2, 4 and 3. So again I will not pick that. And for the same, now I left with 13, 15 and 18. If I choose 13, which is minimum from these three, 13, 15 and 18. So if I choose this 2 to 5, so again that will form a cycle. So I will not choose that. Now we are left with only 15 and 18. So I have to pick this 15, right? So if I pick 15, so it will not form a cycle. Now this is your minimum spanning tree, right? Using the prim's algorithm, right? This is your prim's algorithm. Okay, so it works like that. So I hope you understand it. And if you do some examples, similar type of examples using prim's algorithm, you will definitely learn the concepts in a more better way, and you will remember for long. Okay. Now the next question is your, this is your Dfa questions, right? The question is construct a deterministic finite automata for the following regular expression. It's 0 plus 1 star, 0 0 plus 1 1, 0 plus 1 star. So for that we must understand about what is finite automata and what is deterministic finite automata, and what is this regular expression says, right? So we have this expression, right? 0 plus 1 star, then we have 0 0 plus 1 1, and we have this 0 plus 1 star. Okay, so let's crack this expression. What is this all about? So now if I break this, right, 0 plus 1 star, it means this string, okay, which my machine is going to consider, it will be like that. It can start with 0 or 1, right? It can start with 0 or 1 or any number of 0 or any number of 1s, right? So it start with either 0 or 1, but this can be either 0 0 or 1. So 0 0 or 1 1. Again we can take any combination of 0 and 1. So it will be again can be 0 or 1, can be here we have 1 or 0 or whatever. It can be here 1 or 0, because 0 plus 1 star means any combination of 0 or 1, right? It means any combination of 0 or 1. Any combination of 0 and 1. And 0 0 plus 1 is fixed, because the machine that we are going to build must be like that. It must consider all the combination of 0 and 1, and ending with the 0, any combination of 0 and 1, and starting with any combination of 0 and 1, but in between it must accept the pair of zeros or the pair of ones. So for that you must know the concept of language, concept of finite automata, concept of deterministic finite automata. But because I have to solve this question, so I will explain the concept if you want. And for those students who knows that what is the concept of finite automata, deterministic finite automata, I try my best that I can explain in this questions only the concept of this, right? So let me define the Dfa, right? What is Dfa? Dfa is your deterministic finite automata. It says that we have 4 tuple, right? A tuple of 5 elements: q, sigma, delta, q naught and f, right? Where q is the set of states, sigma is your alphabets, delta is your transition function, right? Q naught is your starting state, and F is your set of final state. So in order to solve this this given question, because for this question we have to plot, or we have to draw a machine which is your Dfa, right? So for that, to draw a Dfa, you must know about the concept of Dfa. What is it? A deterministic finite automata. If you don't know what is deterministic finite automata, you can't solve this question. You cannot draw a machine for the deterministic finite automata, because in exam they are not going to ask again this question. But obviously this type of questions, it can be like other questions, like it says that it can be any combinations, but it ends with 0 0 or 1 1, right? So they can ask you any questions to design or to draw a deterministic finite automata. So let's come back to the what is Dfa. So Q is the set of states. Okay, so in Dfa we have so many states. States is like states can be A, B. States can be Q1, Q2. Means these are the states. So sigma is the alphabet. Alphabet means it can be A to Z. It can be 0 1. Means the alphabet means the elements. Okay, it must be a finite set. It must be a finite set. So in this question, in the given questions, the alphabet is 0 or 1. Only 0 and 1. Okay, so the alphabet is 0 in that case. Then the delta is the transition function. Means transition means आपको कहाँ से कहाँ तक जाना है. Means if I say that we have these states like Q1, Q2 and Q3, Q1, Q2 and Q3, like that we have 3 states, और आपको कहाँ जाना है, Q1 से जाना है Q2, ठीक है, but after reading some symbols, some alphabets. So in that case, if you read Q1 from Q1, go from Q1 to Q2 after reading this 0. So it will be like Q1 comma 0 will take you to the Q2, right? I hope that you are understanding these concepts. So these are the stats, and the transition function is that if you read 0 from Q1, so you will go to the Q2. And it can be the scenario that if I am at states Q1 and I am reading the 1, and then I am going to Q2 or Q3, whatever it can be. So it can be various cases based upon the regular expressions that are given in your question कि आपको दिया क्या गया है. Now Q0 is your starting state, right? Initial state. आपको कहाँ से कहाँ जाना है. तो starting state or initial state is represent like this Q0 and then with this arrow. It means this is your starting state. आप यहाँ से start करेंगे. Means हमें हमारे क्वेश्चन में कहाँ से start करना है कि 0 और 1 का कोई भी कॉम्बिनेशन हो सकता है. तो इस स्टेट पे, जिस स्टेट पे हम इनिशियल स्टेट पर, यहाँ पर क्या होगा, इट कैन एक्सेप्ट 0, इट कैन एक्सेप्ट 1. इसका मतलब ये है कि 0 और 1 के कितने ही कॉम्बिनेशंस आए, आई कैन एक्सेप्ट दिस. और उसको रीड करके हमें कहाँ जाना है, कौन सी स्टेट पर जाना है, नेक्स्ट स्टेट पर. और नंबर ऑफ स्टेट्स का हमें कैसे पता चलेगा, वो हमें फाइंड करना पड़ेगा. फाइंड हम कैसे करते हैं कि हम बिल्कुल ऐसे ही चलते हैं जैसे कि अभी हमने देखा इसमें कि 0 और 1 का कोई भी कॉम्बिनेशन हो सकता है. इट कैन बी एनी कॉम्बिनेशन 0 और 1. तो Q0 पे हमने 0 और 1 को रीड करा दिया, एंड देन 0 0 को रीड करना है, 1 1 को रीड करना है. तो पहले हम Q1 से कहाँ जाएंगे, 0 पे, फिर उससे हम कहाँ जाएंगे, नेक्स्ट 0 पे, ठीक है. फिर Q1 से हम 1 पे भी जाएंगे, फिर उससे नेक्स्ट 1 पे भी जाएंगे और फिर अलग एक स्टेट पे जाएंगे जिसको हम फाइनल स्टेट बोलेंगे 0 और प्लस के 1 के कॉम्बिनेशन से। तो हमें यहाँ पे 4 एटलीस्ट 4 आपको क्या चाहिए, स्टेट्स चाहिए, ठीक है। अब बात करते हैं, अभी इस क्वेश्चन को हम सॉल्व करेंगे आगे भी, अभी आपने यहाँ तक समझ लिया है तो आगे भी समझ में आएगा। सो नाउ F is your set of final states. So sometimes because this is the set of final states, so initial stage will be the 1, but the final state can be 1 or many, right? It can be 1 or many, but in our case that the final state will be 1. Okay, so the final state, we have another representation for the final state. So if this is your final state, let's say QF is your final state, so it is denoted by double circle. It is denoted by double circle. So please understand this basic concepts when we talk about the finite state machine, and we have various types of machine. This is the one type, this is Dfa. It can be NFA, non-deterministic finite automata machine. It can be context free, it can be PDA, right? It can be Turing machine. So these are the various types of machine. This is actually a different subjects altogether, right? Automata or theory of computation. But as I can see in your from your exams, previous year papers, they are asking 3 to 4 questions in every exam, right? So you must understand the concept of this. So let me write this again for you. I am solving this question. 0 plus 1 star, then 0 0 plus 1 1, and then any combination of 0 plus 1 star. Okay, so we have learned about this thing, that the initial state and the final state. So let me write this because this is very easy. So this is your first state, which is your initial state, and this is reading 0 or 1 or any combination of 0 or 1, and then some 0, right? So if I read A0, I can also read A1, right? Because it can be a 0 0 0, it can be a 1 1, right? So for that we have another state Q1. So again, if I have this type of string 0 0 0 and this is again your 1. So to accept that, it must start from 0. So 0 can be read from here, 0. Then after reading 0, it can lead to another 0, which is this 0. This is this one, and then it led to this, because when a state read a symbol, it must go to another state. It must go to another state or to itself. So this is the basic concepts behind this finite machine, right? So now we have to read again this 0. For this 0 we have to, because this is the pair of 0 0 or pair of 1 1, so it can be 0 0, it can be 1 1. So we are reading any combination of 0 1 from this, because this is they have asked, and then we have to read 0 0, okay, in pair of this, and then we have this next state, which is your final state. So final state is represented like this, okay, and this, it can be any combination. So we are again looping to itself, so 0 1, right? So this is for 0 0, and if the case is like 0 1 1 1, so in that case we have to consider this 2. So for this machine, this string will not be accepted, but in question they are asking that it must accept the pair of 0 0 or pair of 1 1 in between, but before, in between these two, right? Any combination of 0, any combination of 0 1, any combination of 0 0 and 1. So for that we have to take another step, right? And this is like, it can be 0 1, and then it can be 1, right? It can be 1. So for that, what we have to do, we have to make this like 1. Okay, but the question is that is this machine is correct according to this regular expression? It is not, because it can be 0 0 0 0 1 is like that, so it must be like this, right? So after reading 2 0, it can be 3 1s or 2 1s again, it can be this. So for that we have to make this, because from this state we have we can go from here to here, right? So after reading 0 and so it will be your like 0, right? And this is your 1, right? So now it is perfect. So this is the answer of your of this regular expression. So I hope you understand. If you have not understand it, so please rewind it and then watch it again, that so that you can grasp the concept of this deterministic finite state machine. Now the next question is, which is your F. Okay, they are asking about that you have to write the algorithm for the recursive and iterative, right? Both recursive and iterative both for the GCD, right? For the GCD and we know that what is GCD, which is your greatest common divisor, right? Divisor, greatest common divisor. So आपसे पूछा गया है कि आप एक रिकर्सिव एल्गोरिथम भी लिखिए और आइटरेटिव भी लिखिए जीसीडी के लिए। तो जीसीडी के लिए आपने प्रोग्राम्स काफ़ी बनाए होंगे, आपने रिकर्जन का भी यूज़ किया होगा। मैं यहाँ पर दोनों प्रोग्राम आपके लिए, दोनों एल्गोरिथम आपके लिए लिखता हूँ। तो रिकर्सिव के लिए हम सबसे पहले बात करते हैं। सो लेट्स फाइंड जीसीडी ऑफ टू नंबर्स, लेट्स से एक्स एंड वाई, राइट। सो द फर्स्ट विल बी if y is equal to 0, then return x, right? You can also calculate, right? If I say that the 2 comma 0, so which is the greatest common divisor, right? You have to return 2 because this value is 0. So that's why we have to consider this case also. And then if it is not the case, right? Else return what? Return GCD of y comma x mod y. So in that way we can calculate GCD of two numbers. So let me take an example for that. We have this example, right? Like 16, like 38, right? So 16 to the 32. This is your 6. This is again your 16, right? So until y becomes 0, it must be calculated. So now 6 and 16, 16, and then this is your 4. Then again 6. This is your 2, right? And now this is your 4, this is right, this is 0. So now the y has become 0, so it will return the 2. So the GCD of 16 comma 32 will be like 38. So okay, 38 will be 2. You can also verify using this recursive program, right? Okay, now the same concept will apply for the iterative, right? For the iterative, first of all we have to name this algorithm is GCD and accept the two numbers x and y. So first will be your, so in that case, because we were we were dividing this again and again until the y becomes 0. So जब तक है ना, जब तक आपका y 0 नहीं हुआ, जब तक आप क्या करते हैं, कैलकुलेशन करते रहे, ठीक है. तो वैसे ही यहाँ हम करेंगे. तो while y is greater than 0, जब तक वो क्या है, y greater than 0 है, so तब तक हमें क्या करना है, what we have to do, we have to do this much. What we have to calculate the remainder after doing x mod y. This is the thing that we are doing again and again, right? Okay, so we have to calculate the remainder. X mod y mod is your operation which gives you the answer, which gives you the remainder in the answer, right? Okay, and now we have to exchange to x to y, and then y becomes your r, and in the next 6th step you will return what? Return x. Okay, so to simplify this, I have already given an example for this, so you can also verify with this and you can learn it from it. So now this question is over, right? Now we have this another questions, the expressions matrix multiplication method for multiplying two matrices of size n cross n, and so that its running time is big of n log 7, right? And then we have this Dijkstra algorithm. So I will explain this in another video, otherwise it will be very long, because it will take another 20 minutes to solve these two questions. So I hope it will help you in your exams and to learn these concepts, as well as you must know if you are a student of computer science. So thank you very much. Thanks for watching.